Okay, welcome back to the channel. As always, all of the code and data sets for today can be found on my GitHub page. Specifically, the data set and code for today will be found within the Data Science and R folder on my GitHub page. And today we're going to be talking about data wrangling or data manipulation. Basically, all of the stuff you need to do in order to actually be able to run an analysis. So typically, we focus so much on how to run the analysis, but we don't really talk as much at the beginning about how to actually work with data, how to take care of, some of the annoying things that can happen with data sets, how to clean them, how to manipulate them, how to work with different variables and search for different filters, stuff like that. So today I'm going to go over all of that stuff. And today I'm going to show a couple different methods to do most of the things today. There are a lot of different ways to skin a cat, so to speak, in R. One of the benefits or downsides to R is that there are a lot of different packages and a lot of different opinions about how to do very similar things. So I'm going to try and show you the approaches that I think are most intuitive and probably make the most sense to me from a logical perspective. And again, feel free to reach out in the comments if you have any questions about anything you see me do today. And this is going to be the first of several videos on data manipulation and data wrangling. So if there's something here that you don't see that's maybe more of an advanced topic, just shoot me a comment or a message and I'll make sure to try and include it in the next video. But just know that this is not intended to be a comprehensive approach to data manipulation. This is meant to kind of introduce you to everything you need to do, as well as some intermediate level things that you might not have known R could do. Okay, so to get started, we're going to go ahead and load up the tidyverse package. There are basically two main approaches to doing data manipulation. You can either use what's called base R syntax or the tidyverse syntax. I don't want to get down into the weeds of the differences. They're basically, both methods work. I think the tidyverse way is a little bit more intuitive to follow along, especially for people that aren't familiar with R. So I'm going to focus on that, but I'll also show how to do some things in what's called base R as well. But again, don't worry about that too much. But just know that's why we're loading the tidyverse package. Today we're going to be working with two different data sets. Let me exit out and let's take a look at what they are. So they're both data sets related to human resources and employee data sets. The first one is going to be the data set that I've worked with in previous videos, where we have employee turnover ratings, so basically their intention of whether or not they want to leave the company, where the larger the number, the more willing they are, or the more they're thinking about leaving, and then a bunch of variables that pertain to different like job attitude and job position variables. The second data set is a kind of a similar data set, except these are actually employees who have either quit or did not quit. So under attrition, a yes means they did quit, a no means they did not quit, and then we have a bunch of different variables that are more related to basically stuff you'd actually see in the workplace, right? The first data set is more like survey type of responses employees might fill out. The second one has more like empirical type of variables, like whether or not they travel a lot, what their pay rate is, how far away from home they are, etc. So those are the two data sets that we're going to be working with today. So the first thing that I want to talk about is how to specify specific columns and or rows using base R, and we'll go into tidyverse in a little bit later. So R has a very specific way of subsetting rows and or columns, and basically the approach is that when you specify your data frame, which for us is called df, these brackets are where you can specify a number or a word that denotes either the position of a variable or an observation or the name of it, right? So basically, if you use a number, right, by itself, that number will automatically choose a column. So I think the easiest way to do this is just to jump right in. So right here, this is how we would subset the first column of a data set. We could either say df brackets just one, right, and we see down here that this gave us our first column, which was the turnover variable, okay? Or the other way you can do this is you can put a comma in front of the one, because the way R works is it works like this. It goes df, then the brackets, it's row followed by column. So you have the row position and then the column position. So if we use this method right here where we do df bracket then comma 1, that's saying all of the rows, because we didn't specify anything in front of the comma. When you leave it blank, that means you want all of them, so all of the rows in the first column. If you don't include the comma, then it's going to automatically assume that you're talking about columns. So either way is fine. I think that it makes it's better practice in the long run to get used to always specifying the comma, so that way you keep it separate in your head that, hey, the first thing is where you specify the row, the second one is the column. If we wanted the third column, we would just switch this to a 3, and when we run it, and then we see now we have the third variable. And let's take a look at our data set. It looks like that's the age variable. Yep, the first observation is 24, and then we see down here at the bottom, yep, there we go. So again, you can specify it by number like we just did, and then you can also say instead the name of the variable. We'll go over that in just a minute. But again, the general approach is that when you are specifying columns this way or rows this way, you say the row number or name first, followed by the column number or name, and then a comma has to go in between them. Okay, so let's move on to, actually, let me make a hashtag so that if you're looking at this, you don't think that's actual code. And let me switch this back to a 1. Okay, if we want to do multiple columns, then we can either do df1:3 and not specify that comma, or we can do df comma, right, and then there's nothing in front of the comma, so that denotes we're keeping all of the rows. And then because we have multiple, now we need to use a C parentheses the numbers that we're interested in. You specify that C with the parentheses anytime you want to include multiple things. So for this instance, if we run this code, now we get the first 3 columns. And so we see turnover is the first column. The company code is this thing right here, the second column, and then the third column is the age. If we look back at our data frame, sure enough, turnover, code, age, first 3 columns. You can also write it like this. Instead of 1 through 3, you can do 1, 2, 3. If we do that, we get the exact same thing. We could also do the first, the second, and the 5th column. We do that, and now we have the first 2 columns, but instead of age, the 3rd column, now we have the 6th column, or sorry, the 5th column, which is the education level. And sure enough, that's exactly what we have. So again, both of this way that I just highlighted and this way work. I would say the second way is probably a better way to keep it straight in your head, so it makes a little bit more sense. So again, because we didn't put anything in front of the comma, that's us saying that we want all of the rows to be selected. But we still have to put that comma there to let it know that we're moving on to the column portion of the index. And so again, that C parentheses is where we put the specific ones that we want to keep. And so I'll go ahead and change this back. Okay, that's how you do it by number, right? And again, we're just focusing on the columns. I'll show you the rows in a minute. But if we want to do column by name instead, we can say df, then a quotation mark, and the name of the column that you want. And just like before, we can put a comma in front of this to let it know that we want all rows, and then just the code column. So when we run that, sure enough, we get that column, that variable, which stands for company code. And if we go back and look at our data set, here's that variable right there. This is the code variable, and that's what we see. So again, you can also specify it by the name. And then of course there's the $sign if it's just one specific column. It's better practice to do this when you're learning, just because this will get you in the habit of, you know, how to then move on to multiple. But again, obviously that the standard R way of choosing a specific variable, you can say your data, $sign, then the specific variable, and that's the same thing. But yeah, so you can either use the numeric position of the row or column or the name of the column. And if you use the name, just put quotation marks around it. We can also do this for multiple columns by name. So here, now we're going to put that same comma in front, right, to denote that we want all rows, but this time we want code and age. So I put that C with that parentheses, just like we did when we were specifying the numbers, and I said code in quotations with a comma followed by age in quotations. And again, that C parentheses is letting R know that we want multiple columns. We run it, and sure enough, we have the age column and the company code column. Okay, so moving on, if we want to specify all columns except the first column, you use a negative sign in front of whatever it is you're interested in. So again, because we just are using the column, we can either specify it with that where there's no comma in front, or we can use the method where we put the comma in front. Again, this is how I would recommend doing it. So we have a blank space in front of the comma to denote we're keeping all of the rows, and then we're saying every column except the first one because it has that minus in front of it. So let me do this. I'm going to say to make a new data object called data frame 3, and I'm saying, hey, make a new data frame that is everything except the first column of the data frame of the old data frame. So we'll go ahead and run this, and now it's created this new object df3, and if we take a look at it with view df3, it should have everything except the first column. Well, let's go back and look at our original data frame. The first column is turnover. Let's go back and look at df3, the new one. Sure enough, turnover is gone. If we look here, this new one has 37 columns, okay? The old one should have 38. And it does, because again, we removed one column, the first column, from the old one. Okay? And so again, you can either do it this way up top or do it down here. This is the method I would strongly recommend. Okay, and so now let's move on. All columns except the first, second, and fourth columns. Well, this is going to be the same approach where we use a negative to say except, whatever columns we're saying, and the only difference is now we're going to use that C parentheses to include multiple columns. So we're going to say give us all of the rows that correspond to all columns except columns 1, 2, and 4. And so we'll do the same thing. We'll make df3 again. And so now we're just making a new data frame 3, that is the same as the old data frame, except it no longer has the first, second, and fourth columns of the old data frame. And so now, if we view this new data frame that we're creating, okay, the first column, which was turnover, right? This is our old one, turnover, that's the first column, okay, it's no longer there. The second column of our old one was code. This is our new one. Code is no longer there, so that worked. And then the fourth column of our old one was gender. And if we look back at our new one, gender is no longer there either. So everything worked out the way it was supposed to. Okay. Well, we already covered that for, oh no, sorry, now we're moving on to rows. Sorry, got confused for a second. So again, remember, our basic approach is that it's the row first, followed by the column. So now, before we were only specifying the columns, now we're doing the opposite. Now we have the first row with a comma to then say that we want all of the columns, because we're leaving it blank after that comma. So if we say df1 comma blank, well, that's saying the first row and all of the columns. So let's run that, and sure enough, we see that first row looks like this person had a turnover level of 2. Their code was AL beige, and their age was 24.14. Let's go ahead and take a look to make sure that's right. Here's that first row, and sure enough, turnover of 2, code of AL beige, and an age of 24.14. So that's how you get the first row and all of the columns. Okay, and now if we move on to the first and ninth row, all we've done now is we're going to keep all the columns like we did before, but now we're going to say multiple rows, and it's just the same thing that we did when we specified multiple columns. We use a C parentheses and then the numbers of the column, or sorry, the rows that we want. So we want the first row and the ninth row, and then we use a comma with a blank to denote that we want to keep all of the columns because it's blank after that comma. Well, let's run that, and sure enough, you can see the row number right here, 1 and 9, and then it's kind of hard to tell because again it's like folding it up into this little space here. Let's clear it actually and run it again. Expand it. Okay, then you can see a little better now. We have the first and ninth row, and we have all of the variables for that first and ninth row. So this would be equivalent if you had a data set on your employees. You could say, hey, I want to look at the all of the information for the first and the ninth employee. So that's how you would do it. If each row corresponded to a different employee, you would say df, or the name of your data frame, and then c parentheses, the rows that you're interested in, then a comma followed by a blank to say that you want all of their columns or their variables. And so finally, we will now talk about how to get specific combinations of rows and columns. So in this example, we want to get the first and fifth row, that's a typo, first and fifth row, and the third and fourth columns. Well, remember, it's still that same basic structure where we have row, comma, column. So here now all we've done is we have C parentheses 1 and 5 for the first and fifth row. Then we have a comma to separate where the columns are going to take over. And then for the columns, we say C parentheses 3 comma 4. So this should give us, for the first and fifth rows, just the third and fourth columns. And so we have the age and gender, the third and fourth variables, for the first and fifth employees. And then, as I mentioned before, we can, of course, use the name instead of the number of the columns. You can't do this for the rows in this specific instance because our rows don't have a name, right? They're just numbers. In some cases, you might have row names. In this case, we don't, but you could do the same thing if you actually had row names. In this case, we don't, so I'm going to say that I want rows 1 through 10, so C parentheses 1 colon 10, because that colon means you want everything in between, the two numbers. So everything in between 1 through 10, and then a comma to denote that I'm now going to specify the columns I want. I could also have written this df bracket and then C parentheses 1, comma 2, 3, 4, and so on and so forth, all the way to 10. But when you want everything in between, two numbers, you could take a shortcut and use a colon. So this is going to give us the first 10 rows for the age and gender variables. So let's run it. And sure enough, we have rows 1 through 10 for age and gender. So that's just a quick intro into how you can choose specific observations and variables and rows. So we'll move on. So now that we've talked about how to look for specific observations and variables, one thing that's important is we're going to talk about some basic housekeeping steps you might want to do, or know how to do at least, when you first get your hands on a data set. So the first thing you always want to do, is do the examine the structure of your data. And the way you do that is you say str and then the object that you're looking at the structure of, which for us is the df. Again, that's the name of my data frame. If I could spell, that would help. So str is the command, and then object is whatever you want to see the structure of, so that's just your data frame. So yours would say object equals whatever your data's name. So you run that, and what this does, and this is really powerful, this gives you an overview of all of your variables, and it tells you the name of the variable. It says what type of variable that is. So you see here, num is for numeric, chr stands for character, and we see again these have letters instead of numbers. And then int means integer. That just means that it's an integer, right? There's no decimals in between. So gender was coded as 0, 1, and it's an integer right now. The reason this is so important to do when you start out is because this will show you whether or not any of your variables are currently being recognized as a type that you don't want it to be. So specifically, what do I mean by that? Well, I want my gender to be a categorical variable. I just coded it as 0 and 1 in the data set, but I want it to be treated as a categorical variable with male and female. Same thing with manager. That's supposed to be manager status, where 0 means they're not a manager, 1 means they are. Same thing with contract type. That's supposed to mean temporary or full-time. In addition to showing you the types, it also gives you a look at what types of actual values you have as well. So in addition to telling you what type of overall variable it is, like numeric, character, etc., it also will give you a preview of what those values look like. That's really helpful if you have a categorical variable, because it'll show you what levels you currently have. So if my gender variable was already coded as a categorical variable, it would say male, female, man, woman, or whatever the levels were. And so that's good to always check and make sure that all of your variables are coded as how you think they are, and that R is interpreting them as how you intended them to be. So always do that first, in my opinion. And so now from what we saw that our gender and our manager status are currently showing up as numbers, right? They're coded as 0, 1. Well, I wanted to recognize that they are categorical variables. So I'm going to say df $gender and make it a factor. That's how you make it categorical. So I'm going to say factor the gender variable and save it as the new version of the gender variable. So we'll do that. We'll do the same thing for the manager variable. And then if your categorical variables are coded numerically like ours are, and you want to give them labels or levels, you can say levels df gender, which is just the data frame in our variable. So the levels are, and then you save them as C parentheses, whatever the levels are. So again, mine was coded as 0, 1 originally, but I want that to represent male and female. So I'm just going to do whatever the variable is. I'm going to say levels parentheses, whatever the variable is. And then I'm going to use this operator to save the levels as, and then C parentheses to combine multiple terms, male and female. And I'm going to do the same thing for manager because I want that to represent that they're not a manager or they are a manager. And now if we do that df again, strdf to look at the structure of our data frame again, now when we go back and look at our gender variable, now it says it's a factor with 2 levels, male and female. And the manager is a factor with 2 levels, no and yes. So again, always good to look at it initially and then after you've made any changes to check your work. If you want to rename any of your variables, you can say names parentheses, the name of your data frame. So in this case, it's names df, and then you use brackets to specify the position of the column. So what do I mean by that? Well, I want to change my first variable to be turnover, my first column to have the name turnover. And so I'm going to say names df for my data frame, and then brackets 1 because it's the first column or the first variable, and I'm saying in quotations what I want that name to be. So let's go ahead and run that. Let's take a look, and sure enough, that first column is named turnover. If I want to make it Bob, let's run it, take a look at it again, and there's Bob. Okay, so let's go ahead and turn it back. So again, this number just switches out with whatever you're interested in. Or another way you could do it is if you wanted to just say all of the names for all of your variables at once, you could just do names df, forget about the number, right? And this is only if you want to do all of them at once. And then we would do C parentheses because we would have multiple, and I would just say variable name 1, variable 2, oh, gotta use quotations, and then so on and so forth, all the way to the end. And so again, that's only if you want to do all of them at once that you can forget about the number, but otherwise you just need to put brackets outside of the names df to specify that you're choosing which position the variable you're switching the name of is. Another thing you can do is if you want to make the names have be all uppercase or lowercase, you can say names parentheses, the name of your data frame, and then 2 upper names df. So we're saying, hey, whatever the names currently are of our data frame, we want to save it as an uppercase version of those names. So I'm going to run this. So now when we take a look, see how everything is uppercase now? And you can do the same thing with lower. You say names, whatever your data frame is, to lower names, data frame. Take a look back, and everything's lowercase again. Okay, if you want to remove a variable from your data frame, that's pretty common. There's a couple different ways you can do this. If you want to just do a single variable, then you would just do df, so this is the name of your data frame, and then the operator to say you're going to save your data frame as the original one minus 39. So this would be getting rid of the 39th variable. Well, I don't actually have a 39th variable, so let's do something, let's do the 38th instead. So again, this is going to get rid of the 38th variable in my data set. So now let's go back to df. And so now at the bottom, now we only have 37 columns. And if I wanted to remove the fifth one instead, I would just switch that to a 5. Okay, if you want to remove multiple ones, then you would just say df, then the operator, and then again df, and now you have to put that comma there in front because we want to tell it we're going to keep all of the rows, and then minus c parentheses the variables that we want. And again, we only use the colon because we want the 37th through the 39th, but I can also do that like this, and I would recommend doing that. So again, this line right here is the one I recommend, not this one up here, just because again this gets you in that habit of getting used to row comma column when you are like using the indexes. I could also have just said the names instead. So if I want to get rid of age, I could have said age and then let's say gender, right? So what this would do is this would keep all of the rows but then delete the age and gender columns. So it's going to keep all of the rows and all of the columns except age and gender. So you can, again, you can do that with either name or number. Okay. And so if we want to relocate a variable column, so let's see, what's a good example of this? Okay, so I have a variable here that is career opportunity. Let's take a look where that currently is. Okay, right here, career opportunity is currently like in the middle of my variables. Let's say I want to move it in front and put it, somewhere else. Well, what I can do is I can say df to denote that I'm going to resave my data frame after I make the change. So df, then that operator, and then the old data frame, and then I'm going to use this symbol right here. This is called a pipe. It's something tidyverse uses. It's a parentheses followed by a caret and then another parentheses. So what this is saying is hey, take the current data frame df and then pipe it, so do something to it, and specifically relocate the career opportunity variable, and then dot before equals education. This is where I'm saying, okay, take the career opportunity variable and relocate it to be before education instead, because remember, currently it's in the middle, it's all the way down here, and I want it to be before education. So I know this kind of looks crazy, but again, this is just where you put the name of your data frame to denote that you're going to resave it as something, and then you write it again because you're saying take the old data frame, and then this pipe just means that you're going to do something to whatever's in front of the pipe operator. So take the old data frame and then pipe, because you're going to do something to it. Specifically, you're going to relocate the variable that you want to move, which for us is career opportunity, comma, and then you say dot before equals the variable that you want to put it in front of. We want to put it in front of the education variable. So let's take a look, and now we see career op is right in front of education. This is really useful because in some functions or packages, they will require that whatever your outcome variable is, if you have one, that it has to be in the first position. And there's a bunch of other reasons you might want to do this instead. And this requires the tidyverse package. So before you can use this, you have to load the tidyverse package, library tidyverse. Okay. So now let's move on to how we get some tables, percentages, and cross-tabulations or contingency tables of your observations. What do I mean by that? Well, let's say that I just want to see the breakdown of how many people I have of each different education level. I would just say, hold on one sec. Okay, I would just say table df $education. And so down here, now it shows me for each of these 7 education groups how many employees are in each level. So I have 4 employees who have no college degree, 28 who have just the most basic, a bachelor's degree, 2 who have started the next level of college, and so on and so forth. And so I'm tabling the breakdown of the number of counts, or the number of observations, the frequencies that fit in each level of whatever variable I'm tabling. So I'm tabling the education variable, and it's showing me how many people are in each group or observations. If I want to get this as a percentage instead, I can say prop.table, proportion table is what that's short for. So proportion table, the original table. So that's just going to convert the original table that we just looked at into a proportion table. And so now what this shows us is that we have the percentage of employees that are in each education level. And so if we were to add all of these up, they would come out to 1, which would be 100%. So it looks like 33% of the employees are in level 3, 17% are in level 4, and so on and so forth. You can also do this times 100 if you just want to get a nice even percentage instead of decimals. And so down here at the bottom, down here at the bottom we have like the first group was like 0.28%, then we have 1.92%, 9.14%, 33%, 16%, so on and so forth. Okay, that's how we do it with single variables. If we want to look at a 2x2 breakdown, or it doesn't have to be 2x2, it can just be any two variables regardless of how many levels they have, we do crosstabs, then a tilde, variable 1 plus variable 2, and then we say the name of our data frame. So again, this is going to give us a breakdown of gender by manager level. And so here we see we have 585 people who were males that were not managers, 244 that were males and managers, and then 524 that were females not managers, so on and so forth. Okay, if I want to get 3 variables cross-tabulated, so say I want to look at gender by manager by education level, I just do the same thing. I do crosstabs, tilde, variable 1 plus variable 2 plus variable 3, and then the name of the data set. So if we do that, it's going to look a little weird at first, but basically what we have here is, if we scroll up a little bit, okay, so it basically starts by the level of your third variable, because remember we have 3 variables, so it can't just present it as a 2-dimensional object. We have 3 dimensions. So what it does is it puts them in an array where we have, for each level of our third variable, which is education, we then have the 2x2 table of the other 2 variables at each level of that third variable. So for the education equals 0 level, we have a 2x2 or a manager by gender table. Then for the education equals 1 group, we have manager by gender. For the education equals 2 group, manager by gender, so on and so forth. So again, because we have 3 dimensions, it breaks it up so that for each level of your third variable or your third dimension, it then gives you the 2-dimensional table that we've been working with, and that's really helpful as well. That'll come up a lot. And so we can also do what we did earlier with 1 variable and convert these into percentages. So if I want to see the percentage of people that fit in each gender by manager group, I just do prop table for proportion table of my original crosstab table of tilde gender and manager from the data equals df data frame. So if we run that, now we see 40% are males who are not managers, 17% are males who are managers, 36% are females who are not managers, and so on and so forth. Okay, and then we can do, sorry, I lost track for a second. Okay, so real quick, what we just talked about with these percentage, these proportion tables, so far what it's been doing is it's been showing us the cell proportion. So in other words, each cell corresponds to a percentage of the entire group of people that we're looking at. So 40% out of all of our observations were males who were not managers. Well, if we want to see the marginal percentages, then we just do what we did before, but now we specify margin equals 1 if we want the row margins, or margin equals 2 if we want the column margins. So it's the same thing as before, prop.table, x tabs, then your 2 variables that you're interested in, gender plus manager, but now the only thing we've done is we've added comma, margin equals 1 if we want row, and then margin equals 2 if we want column. So let's take a look. And so now what we see is before, in this earlier one, all of these percentages added up to 1 together, collectively, because they were percentages out of everybody. But now these marginal percentages, for the row margins, this is showing out of all of the males, 70% are not managers, 30% are managers. For all of the females, 84% are not managers, 16% are. If we do it by column, so we specify margin equals 2, now we have for all the managers, whoops, I think did I hit the wrong thing? Yep, I did. Okay, sorry, give me one sec. Oh, I see what I did. There we go. Now we have for all of the managers, 70% are male and 30% are female, and then for all of the non-managers, 53% are male and 47% are female. So again, when the margin equals 2, you have the column-wise marginal percentages, and when the margin equals 1, you have the row-wise marginal percentages, and this is really, really useful. We can also do this for each each element of our third variable. So if we had that array where we had 3 different variables, so gender by manager by education level, we could get the margins for the third level, which for us is gender. And what I mean by that is if we run this, now we see for each level, so starting with the 7th level of education, out of all of the people who have a 7-level education, or the most advanced level of education, 50% of them are males that are not managers, 30% are females that are not managers, 10% are males that are managers, and then 10% are females that are not managers. Then when we scroll up, we have the next level of that third dimension, that third variable of education, and of all the employees that are an education level of 6 years, 40% are males that are not managers, 35% are females that are not managers, so on and so forth. Okay. Now let's move on to missing data. Okay, it's very important to know, first off, how many missing values you have overall. Just do sum is.na and then the name of your data frame. So I have 80 missing values total. Okay, well that doesn't give me too much information. What if I want to see specifically which variables I'm missing data on? I can use this awful looking thing. The good news is you can actually copy and paste all of this. You don't need to change any of this, not a bit of it. The only thing you need to change is this right here. So just change your data frame. So what I'm saying is I'm saying take this data frame, df for me, and then use this pipe operator. So I'm going to do something to it, and specifically I'm going to do all of this code, which all this awful looking thing does is it gives us a breakdown where each column corresponds to each of my variables, and it shows me the percentage of my observations that I'm missing values for each of my variables. So specifically, for down here at the bottom, for the advisory board variable, I'm missing, it looks like maybe 3% of my observations. And then for the corporate entrepreneurship, I'm missing maybe 1%. The strategic planning variable is the one I'm missing the most on, and maybe 5% of that, and so on and so forth. And so this is really powerful because it shows you specifically visually not only which variables are you missing the most information on, but it shows you visually the percentage of your observations that you're missing for each of those variables. And so again, all you need to do is just change the name of your data frame, and you can paste in this entire thing that I have here. It will require the tidyverse package, so just make sure you load that first. Okay, and then if I want to do what's called listwise deletion, and I just want to get rid of all my observations that have any missing values, I say df, okay, so I'm going to resave my data frame as na.omit my old data frame. So it's just saying take your old data frame and omit anything that has a NA value or a missing value. It doesn't actually have to say NA. You can have a blank like in your data set. It'll still recognize that as missing, but that's just the language it uses. So it's saying take your old data frame and omit everything in there that has a missing value. So if we do that, and now we check and see how many total missing values we have now it's 0 because we deleted all the observations that had missing values. Okay, moving on. Okay, so now let's talk about selecting and filtering with tidyverse. What do I mean by that? Well, the easiest way to explain it is to look at an example. If I want to extract all the employees that are at a specific facility, if I want to look at all employees who are at the specific facility that's coded LV, then what I'm going to do is I'm going to make a filtered data frame, a new data frame. Again, you can call it whatever you want. I'm just calling it df_filt to let me know that that's the filtered one. I'm going to make this new data frame that is the version of my old one where I have piped a filter, and that filter is gender equals male. Importantly, you have to use double equal signs if you're doing what's called a logical proposition. In other words, a logical proposition just means when you're doing something that's coded as either like true or false, right? So in other words, like this is going to tell R to search for every observation where gender is male. And so again, you cannot do one equal sign. It has to be two equal signs. So again, just to recap, I'm making a new data frame that I'm calling dfFilt, and I'm going to take my old one and apply this filter where I'm filtering for only the people whose gender is male. So I will take a look. And so now if we look, my original data set had 1,450 people. Now it only has 804 because I got rid of everybody who wasn't male, and we can see our gender is only male. Okay, if I want to do the same thing, but then sort the results by something else, so let's say I want to pull or filter for all the male employees. Sorry, this was not at facility LV. I don't know where I got that from. If I want to filter by all of the male employees and then arrange in descending order by their turnover intention levels, well, I'm going to, make this new data frame that I'm interested in. You can call it whatever you want. I'm going to call it dfFilt, and then I'm going to say, make that a version of the old one where you apply a filter for gender being equal to male, so filter for only the males, but then apply another operation to it where we're going to take this data set that has been filtered to just have the males and then arrange it in descending order by the turnover level. So let's take a look at it now. And if we go back to this new dfFilt, you see how the turnover level starts with the 5s and then goes down, in order. Well, we took our data frame that still only has the males, but now we've sorted it by turnover level, whereas we didn't do that previously. We just filtered for just the males. If you want it in ascending order, then you do the same thing, but you just leave out this desk part. You just say arrange by turnover. And so if we do this, now it starts with the lowest values of turnover, and it's still only the males. So just to recap, this is where we are filtering by one condition and then sorting the results by something else. If we want to filter by multiple conditions where all of the conditions must be true for it to be included, we could do something like this where we want to have only those observations where they're males and they're managers and they have a turnover level of less than 3. So this would be saying, hey, make a new data frame dfFilt, and it's going to be the old one where we apply a filter for gender equals male. This and sign is how we denote that we are having multiple conditions. So they have to be male, and they have to have a manager status of yes, and they have to have a turnover of less than 3. So now let's look at dfFilt again. And now we only have 184 people because, again, they have to be male, they have to be managers, and their turnover level has to be less than 3. And we can see from our turnover variable, our gender, and our manager that that is true. If you want to filter by multiple conditions where one or more must be true, so in other words, this way not all of those conditions have to be met, just one of them has to be met to be included, then you use the bar instead of the and sign that we just used. So this is going to do, take your original data frame and filter it for manager equals yes, or gender equals male, or turnover is less than 3. And let's take a look, and now again we have 1,294 observations this time because, again, they could either have a turnover level of less than 3, or they could be male, or they could be a manager. And so we can see by looking at these observations that very few of them satisfy all those conditions because they don't have to. They only have to satisfy one. So again, just to recap, we've covered filtering by one condition. We've covered filtering by one condition and then sorting for something else. We've covered filtering by multiple conditions where all of them have to be true. And then we've covered by filtering by multiple conditions where just one or more of them must be true. Now let's talk about how to make new variables or alter current ones. So what we're going to do here is we're going to alter a current variable, and specifically we're going to take our original age variable right here, this is our original age variable, and we're going to add 10 to it. So what we have here is we have df, so we're saying save a new data frame as the old one, but then applying this mutate operation, where mutate is how it's the function that we use to change or make new variables. So we're saying take the old data frame and then apply this mutation to where the new variable is going to be called age, because it's the same as the old one, but the difference is now that age is going to be equal to the old age plus 10. And now we're using just one equal sign because this isn't a true-false condition. It's not a logical condition. We are literally saying save this age variable as the old one plus 10. So if we go and look at df, now our ages are the old ages plus 10. This first observation used to be 24.14. Now it's 34.14. So in this instance, we just took a current variable and we applied a mutation to make it a different version. So we did something to it. We could also, you can literally do anything. So we can say like age times 10 if we wanted like 10 times the original age variable. If I want to go back and I want to basically erase what I did, I can say, okay, well now I want to do the same thing, but I'm going to do age minus 10 to get back. So now if we go back and look, sure enough, that first observation is back to 24.14. I've just showed you how to do it with plus or minus, but again, you can do this with pretty much any operation that you're interested in. And so now we're going to make a new numeric variable as a function of the old one. And so the difference here is that up here we said take this variable age and just make it the same name as the old one, but then add 10. So we were just changing a current version of the same variable. Whereas here, now we're making a new variable called age squared, and that's going to be the old variable caret 2 raised to the second power. So again, same thing, I'm just taking the old data frame and I am saving the new one as a version of the old one where I have applied a mutation to where I'm making a new variable called age squared that equals the old age variable squared. Then if we look, by default it will add it to the very end, and then you can relocate it using the tools we looked at earlier. So at the very end we have age squared at the end, and we could relocate it to be near the new age variable if we wanted to. You can also make a new variable based on text patterns in the current variable. So if I want to make a if I want to make a new variable where I am going to, sorry, it's kind of hard to explain without doing, let me run it first, then I'll explain it. So what I did is, you see this variable called facility? I took the code variable and I said take the first two letters of that code variable and make that facility, because the way this code variable works is the first two letters represent a specific facility, and then the word after, so AL represents the facility AL, and then beige represents a specific department. So what I said is, I said, okay, well, I don't want the entire code with their facility and their department. I want a new variable that just has the first two letters, because that's the facility, that's what I'm interested in. So what I did was I said, okay, take the original data frame, apply a mutation to where this new variable facility, that's the new variable name, is equal to a substring of the original variable, which was x equals code, because that was the original variable, and then I'm saying start with the first letter, stop with the second letter, or it could be numbers as well, right? If this code was a numeric code instead of letters, I would do the same thing, and this would pull the first and second numbers. So again, what this is doing is this is saying take a substring of the original thing, which was the code variable, start at the first letter, stop at the second letter, so combined that pulls two letters. But again, don't lose sight of the fact that we are making this new variable called facility, and we're doing that by applying a mutation to something. And then, like we said before, we can relocate that to be before the age variable. And if we go back and look, it is before the age variable. And if I want to make it a categorical variable, which it should be, right, because it's a facility, right, it's not a number, it's just the facility they belong to, I can do df $facility and then save that as a factored version of the old df $facility. Okay, and so now here's a little bit more complicated mutation. So this is going to make a new categorical variable based on a continuous range. So this takes the continuous turnover variable and creates 4 risk categories based on whether they fall within certain ranges on that continuous variable. So let's just do it and then look at it. So I'm going to run this code, and then when we go back and go all the way to the end, because remember that's where they put it in after you make it, we have a flight risk variable now right here, this column, where what we've done is we've taken the employee's turnover intention levels, which was a continuous numeric variable, and based on the values of that turnover level, we've decided to categorize them as certain, categories. So like very low risk of leaving, low risk of leaving, moderate risk of leaving, so on and so forth. So the way we did this is we said, save this new data frame as a version of the old one where we apply a mutation, and the new variable we're creating is flight risk, and it equals, and then this is this thing called case when, and this is where you can apply multiple like if else statements kind of. So basically what I mean by that is if the turnover variable is less than 1.99, less than or equal to 1.99, code that person as very low risk. Then comma, if the turnover is between greater than 1.99 and less than 2.99, code them as low risk. Comma, to move on to the next one, if the turnover is greater than 2.99 and less than 4, code them as moderate risk. Comma, to move on to the last one, and then you just say true, because if they fit in this last category where there's nothing else left, then that's true, and if that's true, they are high risk. So again, this is how you can take a continuous variable and split it into multiple categories. Okay, so now we're going to look at combining filtering, mutating, and arranging. So this operation that we're about to look at filters for only employees at the facility LV and then makes a new variable called turnover risk, where if they have a turnover intention level of 3 or greater, they're classified as high risk, and then those results are then sorted in descending order, such that the high-risk employees are listed first. Now, I know you're probably thinking, hey, didn't we just do this? We kind of did, but before we looked at only splitting a variable into categories. Now we're going to look at how we could first filter, then split them into categories, and then sort them based on these new values. So basically, the scenario is that we want to make a risk category, a risk label, where first we filtered for only the employees that are at the specific facility, and then for just those employees that are at the facility named LV, for just those employees, we're going to then categorize them as high risk or low risk, and then we're going to sort them by that new variable that's called TI, or turnover intention risk. So basically, I'm creating this new thing, this new data set, where I'm calling it high risk underscore LV to let me know that it's going to be just the high risk folks that are at high risk of leaving at the facility LV. And I'm going to take my old data frame, I'm going to apply or pipe this filter for facility equal LV, so filter for just the folks that are at the facility equal to LV, and then apply another operation. Specifically, I'm going to apply a mutation where this new variable ti underscore risk equals an if else statement, where the way this works is if turnover is greater than or equal to 3, comma, call them high risk, and then comma, if the turnover wasn't greater than or equal to 3, then they automatically become low risk. So again, this is like a simplified version of the case when, where the way this works is if this first condition is met, so if turnover is greater than or equal to 3, comma, well, this is the yes, they become high risk. Then if that condition isn't met, comma, that's a no, and they become low risk. Okay, we're going to take that new variable, that risk level that we've just created, and then apply one last operation with this pipe. Specifically, we're going to apply the operation where we arrange in descending order of this new variable turnover risk. So let's look at it and maybe it'll make sense. So we created a new object, so I need to view it. And so again, we see it's only the folks that are in the LV facility. And if we go all the way to the end, here is their turnover risk. And we have sorted it so that it is in descending order by high risk all the way down to low risk. And again, it's only the folks that are at this facility, the employees of the LV facility. And then all of these folks had a turnover level that was either less than or equal to 3, in which case they were coded as low risk, or greater than or equal to 3, in which case they were coded as high risk. So we applied a single filter of having to be at the facility equals LV. Then we applied a mutation to make a new variable called turnover risk based on the values of an old variable. And then we applied one final function where we arranged these observations in descending order of this new variable. Okay, we'll do another example. So this is going to filter for only the males that are over age of 10, and then makes a new variable called age squared by squaring the original age values. Then those results are sorted in descending order by the new age squared. Not as complicated as it looks. We're creating this new thing, this new data subset called old man age squared, where we're going to take our old df variable, we're going to apply a filter for just the gender equal to male and age greater than 10, because we want only the males that are over 10. If we wanted either male or age greater than 10, we would use that bar, remember? But because we want the males who the observations that are because we want the observations that are both males and over 10, so the males over 10, we use the and. So filter for just the males over 10, then apply this mutation where we create an age squared variable that is the old age squared, then apply one more thing where we will now arrange by descending order of this age squared. Why you would want to do this in real life, not sure, but there's a lot of instances where you would want to do something that's actually useful. For example, we could filter by just the males that are over 10, create a new variable that is basically something like that risk assessment we just made, and then sort by that risk assessment. So that would give us all of the older males who are at a high risk of leaving. So that's like a more tangible real life example of why this would be useful. But let's go ahead and do it. We'll go ahead and view it. And sure enough, we have only the older males. We can see that by our age and our gender. And then we created a new variable down here at the back that is age squared. And you can also use head if you don't want to look at the entire thing, to just make sure and check your work by looking at the first 5 columns, or 5 rows, sorry, or 6 rows actually. So what we see is that this gave us the first 6 rows of that high risk LV thing that we made, and then this gives us the first 6 observations of all of the males that are older and fit our previous filters. So again, this head thing, this is just an alternative to view, where this lets you see the first 6 observations / rows of a data set. Okay, moving on. Okay, moving on. So now let's look at summarizing and how we can combine filters with summary statistics, and then how we can group by people in different groups or observations in different groups. So let's say that we want to summarize where I get the mean turnover level or the mean turnover intention of all of my employees. So basically, I'm going to take my data set df and I'm going to apply a summary statistic where I say summarize. This is the name of my new variable. I'm going to call it mean turnover, and it's equal to the mean of my old variable turnover. And so again, you can apply any summary statistic. It doesn't have to be the mean, but the basic pattern is that you summarize and you specify first the name of the new variable you're creating, or the summary statistic you're creating, and then it's going to be equal to the summary applied to a current variable. And so down here at the bottom, we see that my overall turnover level for all of my employees is 2.12. And so we can verify this. And sure enough, my mean of my turnover is 2.12. I know you're thinking, well, why wouldn't I just do that instead of this complicated thing? Well, the complicated version that we just looked at is going to be really important for some more complex stuff. So just bear with me for a minute. Like I said, it doesn't have to be the mean. It can also be the median. And so if I want to summarize and use a median summary statistic, then it's going to be take the df data frame and apply a summarization where I summarize, and my new variable is called middle age, and it's going to be equal to the median of my old age variable. So this should just return just the overall median age. And down here, the median age is 36.64. And we can verify this. Yep, the median of my age variable is 36.64. Okay, so look, now we'll start to see why we might want to use the summarize, which is a little more complicated than just the straightforward, operation itself. Well, we can pipe it so that we do multiple things. So I can say, take my data frame, apply a filter for just the males, and then make a summarization where this new variable min average turnover, or the average male turnover, gives me the mean of turnover. But again, because we applied this filter beforehand, this is going to return just the average turnover level for just the males. And down here at the bottom, sure enough, the average turnover level for just the males. I can do the same thing with a numeric filter, right? So let's say I want to filter for just those employees who are older than 10, and then get their average pay satisfaction. So my new variable will be called mean pay satisfaction, and it's equal to the mean of my old pay satisfaction. But importantly, it's only for those employees who we first filtered to have an age over 10. And so now we see at the bottom, the average pay satisfaction rating for all of the employees whose age is over 10 is 3.37. Now let's talk about group by and summarize. So group by, this is really important. This is probably the most useful thing that I can think of that I'm talking about today. So this lets me group by levels of another variable and then apply some operation, which we're going to start with a summary. So I'm going to take my data frame df, I'm going to apply a group by gender, so I'm going to group by the males and the females, and I'm going to apply a summary where I'm creating a new variable called middle pay satisfaction that is the median pay satisfaction level, so median of the current pay satisfaction variable. But if you see when we run this, it's now going to do this for just the males and just the females. And what this shows us is that, hey, there is no difference in the median pay satisfaction for the males and the females. But importantly, we grouped by gender level first before we did that, and that can be any grouping. So let's say we want to do it by the managers and the non-managers. Let's see if they're equally satisfied with their pay in terms of the median. And we can see, no, the median is different for the managers, which makes sense because they're probably getting paid higher. So the median pay for the managers is 3.67. For the non-managers, it's 3.33. So as you can see, this is a super, super useful operation. So again, this is grouping by some level of a variable first and then applying a summary statistic to each level of that variable that you group by. We can also get multiple summary statistics and in addition to just one of them. So let's say I want to group by the facility that employees are from. So I'm going to first group them by their facility that they work at. And then I'm going to summarize, and I'm going to get two variables. I'm going to create a first one that's called mean turnover, so that's their average turnover level. But I'm also going to ask for the max age, and that's going to be equal to the maximum age. So what this is going to do is this is going to tell me the average turnover level for each facility and the oldest age in that facility. And to get the multiple summary statistics, you just do the first one and then comma the second one. So super easy. You just add a comma, then type your next one. And that can be, again, any summary statistic, but it's the same pattern where you type in the name of your new variable that you're creating, and that's going to be equal to the summary statistic that you choose of whatever old variable you're looking at. And so when we run that, what we see is this gave us for each of our facilities the average turnover level and the maximum age. Again, this is something that's super useful in any context. Okay, and now let's say that we want to group by facility and then create not only the average turnover and the maximum age, but we also want to get the median pay satisfaction. So all we've done is now we've added a third summary variable, and it's going to be called middle pay equals median pay satisfaction. So let's go ahead and run that. And let me move this over so it's a little easier to see. Okay, and so what we have here, the old data frame, apply a grouping by facility, then apply a summarization where we get our new variable is mean turnover and is equal to the mean of the old turnover level. The max age is equal to the maximum age, and the middle pay new variable is going to be equal to the median of the pay satisfaction variable. And so sure enough, we look at our results, we have facility, average turnover, maximum age, median pay. We can also filter before we group. So let's say that I want to filter for all the people that have a turnover level that's greater than or equal to 3, and then group by gender, and then get a summary. And so let me make this a little easier to look at. So what this is going to do is this is going to take my data frame, it's going to apply a filter. I'm going to filter for just those people who have a turnover level of greater than or equal to 3. I'm going to group those people by gender and then create a summary statistic where the mean pay satisfaction gives me a mean pay satisfaction. And so we have for just those people, out of just those people who have a turnover level of greater than 3, the males then have a mean pay satisfaction of 3.01, and the females have a mean pay satisfaction of 2.98. Well, if you remember, when we didn't first filter, when we just grouped by gender, there was no difference. But once we filter by their turnover intentions first and then group by gender, now we have a difference. Another example is we can take our data frame, we can apply a filter for just the people who have a turnover of greater than or equal to 3, group by facility instead of gender, and then get two statistics like we did before. So we're going to get an average pay satisfaction and an average perception of fairness. So basically this is how fair they think they're being treated. So again, this is going to first filter for just those people who have turnover levels of greater than 3, and then for those people we're going to group by facility and calculate the average pay satisfaction level and the average perceived fairness level by facility for just those employees who have a turnover of greater than or equal to 3. And sure enough, here we have it, the facility, average pay, average fairness, and again, this is just for those employees with the turnover level of greater than or equal to 3. We can do multiple group bys, so instead of just grouping by facility or gender, we can group by facility, comma, gender, so you do data frame, apply a grouping by facility, comma, gender, facility, and gender, and then summarize a middle pay that is equal to the median pay satisfaction. And so what we have now when we look at it is we have each facility, but there's 2 rows for each facility because for each facility we then grouped by the males and the females, so it's a double level grouping. So at the facility AL, the males have a median pay satisfaction of 4 and the females have a median pay satisfaction of 4. At the DW facility, the males have a median pay satisfaction of 3.33. The females have a median pay of 3. So this is really powerful because this would let you group by one level and then further drill down deeper to then compute a summary statistic at another level. This is really, really common in the business world as well. Okay, and so now let's talk about how we could group by, apply a summary statistic, and then filter based on that summary statistic. So the example is that let's calculate the number of employees and their average pay satisfaction by the facility. So we're going to group by facility and then calculate their average pay and the number of number of employees at that facility. Then once we've grouped by and calculated those statistics, we're going to then filter the results for only those facilities that meet specific conditions. So specifically, they have to have over 10 employees and an average pay satisfaction of above 2. So the way we do this is we're going to say take our data frame, we're going to group by facility, and then we're going to then summarize. And this is the same thing we've been doing. I just spaced it out so it's a little easier to look at, but I could have also written it like this. I probably just need to do that so it's consistent. Give me 1 sec, sorry. Okay, sorry about that. I just want to make it consistent. So again, we're going to take the data frame df, we're going to group by facility, and then we're going to summarize in, that's the name of our new variable, and it's just going to be in parentheses, that's just how you count, so it's going to give me the number of employees by facility. And then I'm going to create the other new variable because I have a comma to denote that I have 2 variables I'm creating. The other one is going to be a summarization called average pay satisfaction, and that's just going to be the mean pay satisfaction. Once I do that, I'm then going to filter based off of those results for only the only the facilities that have more than 10 employees, so n greater than 10, and an average pay satisfaction that's greater than 2. So just to recap, we're going to group by facility, calculate the number of employees and their average pay satisfaction for each facility, and then filter for just the facilities that have over 10 employees and an average pay satisfaction that's greater than 2. And sure enough, we see for each facility the number of employees, and if you look, there's no facilities here that have fewer than 10 employees because we filtered all those out. And then their average pay satisfaction, same thing. There's nobody with an average pay satisfaction that is not greater than 2. Another really cool thing is you can use what we just learned how to do and actually take these summary statistics by group and then plot them. So let me explain first. The first thing you do is you create an object. So I'm going to call it by_facility, and I'm going to store this new object that I'm creating as the old data frame where I apply a grouping by facility and then create our summary statistic just like we've been doing. So at this step, I'm not doing anything different. I'm just grouping by facility and creating a summary of an average pay satisfaction for each facility. So let's do that. Let's take a look at this object that I've created. So I'm just going to type in the name of the object. And as you can see, again, it's just literally the same thing. It's each facility and their average pay. Okay, what's different though is you can use that object that you've created and then create a plot. So I'm going to do ggplot, the name of the thing I just created, so by fac. So technically it's data equals by_facility. And then I'm going to create a mapping where an aesthetic where I'm going to have the name of the thing the name of what I'm grouping by. Let me just plot this. That'll be easier to explain. Okay. Sorry, I kind of butchered that. Basically, what I was trying to say is that we grouped by facility, we calculated that average pay level, and then used that object that we created. Instead of just looking at the numbers like we had before, we stored that as an object, that result as an object, and then we can plot it. And so what this has done is look at our y-axis. It says average pay. That's that average pay satisfaction variable that we created, but because we stored it as an object, we were then able to plot it. So at the bottom we have each facility, and then we have a color that corresponds to each facility, and then that average pay satisfaction is what we plotted, and the size corresponds to basically how large it is. So a smaller circle means a smaller level of pay satisfaction. A larger one means a larger average level of pay satisfaction. So this is really cool because we were able to take those results and not just look at the numbers, but then use them to plot a graph of the results. So if I was an employer, I could look at this really quickly and I could see, okay, right away, which facilities visually have higher average pay satisfaction levels and which facilities are the employees not as satisfied with their pay. So by looking at this, the DW facility, those employees aren't too happy with their pay, whereas the MP facility and the AL facility, they are pretty happy with their pay. And we'll do the same thing but with average turnover. And so now we're going to do by facility 2. And so same thing before, we're just going to make a new object this time instead of just looking at the results, and it's going to be our data frame where we apply a grouping by facility and then summarize, and the summary we're making is the median turnover level this time. So instead of average pay satisfaction, we're looking at median turnover level by facility. So again, I'm just going to store it as an object, those results, and then I'm going to plot them where I do the ggplot, and then the data is equal to that object that we just created, and then my x variable is going to be by facility, my y variable is this new object that I created, and then I'm going to color it by facility, or the grouping variable, and the size is going to correspond to the new variable I created. So again, the data is the results that we just pulled, and then the x-axis is going to be our group, which was the facility. The y variable is the variable that we created, and the color is by our grouping, and then the size is the value of that variable we created. And so here we see this is again is the median turnover intention level. So if we look at this facility NE, this is a facility where the employees have higher levels of turnover of wanting to leave, so this is turnover intentions. This would signal to me, if I was a manager, that I need to look at the NE facility because those employees look like they want to quit their jobs at a higher rate than the other facilities. Whereas if we look at the facility LH and AL, those employees seem to be a lot happier. Okay, and then another one we can do really quickly is we can group by facility and gender, summarize the median pay. So let me just do that real quick. So I'm going to do by fac underscore gender, and then let's look at what that is real quick. And so what that was that grouped by facility and gender. So for each facility and then each gender level within that facility, what's the median pay satisfaction level? So we stored that as the by facility 2 argument, or whatever you want to call it. And now we're going to plot it. So, we actually stored it as the by facility gender, or the by fac gender argument. And again, we're going to do the same thing. We're going to plot it. So ggplot data equals by fac underscore gender, and then x equals facility, because that's our x-axis. The y equals mid pay, that's that variable we just created above. The color by gender, and then the size by mid pay. And so what we see is for each facility, we have 2 different colors that correspond to our gender levels, and we can see by facility whether or not different facilities appear to have gender discrepancies in terms of how satisfied the employees are with their pay. So if we look at the FJ facility, well, the turquoise is the females. It looks like at the FJ facility, the females are more satisfied than the males in terms of their median pay satisfaction levels. And then some of these you only see one color. That's because that facility might not have had any female employees, right? These are small companies, hypothetically. But again, this is really powerful because it lets us see by 2 different grouping levels what these trends are. So by facility and then by gender level if there's any differences in median pay. So we can see the differences in pay satisfaction not only across the different facilities visually, but also within each facility whether or not there's gender differences. Okay, the last thing that I want to talk about with the tidyverse is called pivot longer and pivot wider. So real quick, let's take a look at our data set. This is our original data set. If we scroll over, we see that we have 9 HR variables, HR 1 through 9. What these represent is for each row is a single employee, and each column, each of these 9 columns, are their responses to 9 different surveys administered by the HR department. So again, each row is an employee, and then each employee responded to 9 different surveys at 9 different points in time. This is called wide format, and what I mean by that is that we have multiple time points grouped into this one row. The long format would be where each row would correspond to a single survey. So what I could do is I could pivot to make this into long format instead of wide format. So what do I mean by that? Let me show you the results, and then it'll be easier to explain. So again, just remember right now each row is an employee, and there's 9 columns for each of the 9 employees. Or sorry, there's 9 columns for each single employee, 9 HR columns, and each column corresponds to one response to one survey by that employee. So each employee responded to 9 different surveys over these 9 time points. And if we pivot longer, what it's going to do is, if we scroll over now, we grouped by a new variable. We made a new variable where we basically collapsed upon these HR levels. So now, instead of each row being a single employee where each employee had 9 different columns, now we have each row corresponds to just one of those HR surveys. And so 9 different rows correspond to a single employee because we've now plotted collapsed upon the 9 different responses. So if you look at these other variables, we see they have the same values. Well, that makes sense because again, it's the same employee. What we've done now is we've just collapsed upon the 9 HR columns, and the rest of the columns had to repeat because it's the same employee that now has been basically expanded into a long format where each row corresponds to one of their responses to the 9 HR variables. And then the rating column basically took the values for each of their responses to those 9 HR columns. So again, let's look at the original one, HR 1 through 9. This first row is one employee, and here's his 9 responses to the 9 different HR things. Well, in what we just did is we pivoted to a long format, which is just like a pivot table, sort of, and we have collapsed it down to where this now single row corresponds to each of those 9 survey responses. So that's pivot longer because we went from the wide format to the long format. And so now if we look, this is our new data set. It has 12,600 rows. The original data set had 1,400 rows. Well, 9 times 1,404 is 12,636. So the original 1,400 rows then got basically expanded because now each employee, each of the 1,400 employees now has 9 different rows. That's pivot longer. So the way this works is you specify what it is you want to save this as. So we saved it as df2, and that is the original df where we apply the pivot longer. We specify the columns that we want to collapse upon or make longer. So for us, that was columns HR1 colon HR9, HR1 through HR9, then a comma. We said what we want the names to be. So we basically took those old variables where it was this is the old one. So we took these old ones and then we now collapsed it into the new one, and we said that we're going to name that new variable HR, and then we took the values and called them a new variable called rating. So the old one, where again we took the names of the columns from the old one, we collapsed those into a new variable called HR that just has HR1, HR2, HR3, etc. as its different values. And then we took these numbers here and we specified that these values, these numbers, are now going to be made into the rating column. So with the pivot longer, you first say the columns you want to collapse or change from wide to long, you specify the names that you want the original column names to now be like put into. So we pulled those into the new HR variable. And then you say where you want the values to be go to. So we wanted those values to go to the new rating variable. So now we decide this is awful, right? Because this is a bad example of when we would want to do this in real life. We decide that we want to go back to 1 row per employee like it was before. We need to tell R how we want to handle those duplicated values in the other columns. Because remember, if we look, because this is the same employee repeated 9 times now, these are all duplicates. So when we go back to wide format, we have to tell R how to resolve that issue. And so the easiest way to do it is we're just going to say, hey, values underscore function equals mean. That's where you tell it how to handle duplicates. So what I'm saying is I'm telling R, hey, any duplicated values, when we go back to our original format, just take the average, right? Because if they're duplicates, if you take the average, you're just going to get, whatever the single value is. So what I'm going to do is I'm going to store this new object as df2, and it's just going to be the old one, but now I'm applying pivot wider. And so I'm saying where the names are coming from this time. So the names are coming from the HR variable that we created. I'm saying, hey, take those names from HR, and then the values are going to come from the rating column, right? Because in this new data set, we have the names of the columns stored in HR and the values stored in the rating column. And so I just tell R, hey, pivot wider, take the names from the HR column that we made and the values from the rating column, and then the duplicates just take the average. And so let's take a look. And so this is now back to normal, where if we scroll over, now we have HR 1 through 9. So we're back to wide format. Pivot longer and pivot wider are kind of hard. They just take a little while to get used to. I highly recommend you play with it a lot because that's a really valuable skill. Another thing we can do is we're going to take a look at the other data set that we loaded. Let's say we want to identify certain phrases. So specifically, I want to identify any columns that contain the phrase rate. So what I'm going to do is I'm going to create a new object called A. It can be whatever you want to call it. And I'm going to say, hey, take the column names of the DFB data set, which, let me show you what that is. That's just the other one that we loaded earlier. That's this data set. That's just the other HR data set. So I'm saying, hey, take those column names from that data set, apply this function called grepl, and then you just specify the pattern you're looking for. So I want it to identify anything that has any columns that have the name rate. So I'm saying, hey, look for the pattern rate, and then I want you to look within the column names of that data set. And so if we look at what this did, this returned all of the column names that match that pattern that I specified. And you can use this grepl to look for anything that matches a certain pattern, right? So we don't have to just look for column names. That's just an example I used. So again, all I did was I said, hey, I want you to look within the column names of this data set DFB and look for the pattern rate. And so this would be useful if I just want to, if I have a data set with a ton of different columns and variables and I just want to quickly look for any of them that have the name rate. The reason I might want to do that is I might want to say, hey, well, currently, if I look at this, I have 3 different columns for my different pay rates. I have a column for hourly rate. I have a column for, if I can find it, a column for monthly rate, and I have a column for daily rate. So I know that by looking up that pattern. So I might decide, okay, well, currently it's in wide format where I have 3 different columns for these 3 different pay rates. Well, I decide that I might want to use long form. So after I do this, each employee will now have 3 rows where the first row contains the pay rate at the daily level, the second row contains their monthly pay, and the third row contains their hourly pay. So what I would do is I'm going to do pivot longer now, because currently it's in wide format where each column is daily rate, column for hourly rate, and column for monthly rate. So what I would do is I would just say the name of the new object I'm creating. So that's going to be dfb2. That's going to be my old dfb. I'm going to apply a pivot longer. I'm going to say the columns that I'm looking for, specifically like what columns I'm collapsing. I'm looking for all of A. And A, remember, A just contains the names that match that pattern. So what I'm saying is I'm saying, hey, I want to apply this pivot longer to all of the columns that have rate in the title. And I want to make the new variable pay frequency. So I'll have a variable that's called pay frequency where there's going to be 3 different values. There's going to be daily rate, hourly rate, and monthly rate. And then I want to take the values for those pay rates and make that a new variable called pay amount. So if we do that, let's take a look. We're going to take a look at this new object, this new data frame we created. And now if we go down to the end, now instead of a different column for daily rate, hourly rate, and monthly rate, now we have a drop down where for each employee we have a row for their daily rate, a row for their hourly rate, a row for their monthly rate, and it's in long format because, again, this is all in one column. And then we have the pay amounts that correspond to each of those rates. So instead of having 3 different columns for the 3 different pay rates, now their pay information is contained within one single column. But again, all of the other variables had to be duplicated because it's the same employee for all 3 of these rows. And if we want to go back to wide form because we want each employee to just have one row after all, we decide, okay, screw it, we'll just go ahead and, you know, let the columns repeat after all. We might say, okay, take the dfb2 object that we just created, the data frame, and now we're going to resave it as a pivot wider where we're going to pull the names from. Well, the names are just coming from that variable we created, pay frequency. So we're going to say, hey, the names for the columns that we're going to go back to wide form, those are going to come from that pay frequency column or variable. And then the values are going to come from the pay amount. So again, we're just specifying when we go from long to wide, we specify where we pull the names from, which is this column, and where we pull the values from that are going to go into our columns. And that's from this, the pay amount. So names from equals pay frequency, values from equals pay amount. And let's take a look at it now. And then sure enough, now it's back to wide format where each row is one employee and then they have a column for daily rate, hourly rate, and monthly rate. And that's wide format. Okay, so let's say that we want to get the first, let's say that we want to get some substrings or matching patterns, kind of like we talked about briefly. Let's say we want to get the first 2 letters of the company ID code and then make a new facility variable. Well, we did that earlier, right? That's when we took the company code that had 2 letters that corresponded to the facility and then the rest of the letters corresponded to their department. Well, again, what we would do to do that is we would just say, hey, take our data frame, apply a mutation where we create this new variable facility that's equal to this function string sub that's applied to the code variable, because that was the name of the original. I'll show it to you. Remember, this was our original variable. This was the company code where these first 2 letters in capitals, those correspond to the facility. The other ones correspond to the department. So we would say, hey, take that variable code and look for the first and the second letters, and then use those to make this new variable called facility. That's the mutation. And we already did this earlier, but if we apply it again, let's take a look at it. So what it did was it just pulled those first 2 letters from the code variable and made a new variable called facility. And the way that it did that was by you specify where you are pulling from. So the code variable, you say where you start. So we start with the first letter and we stop with the second letter. So that would be start equals 1, stop equals 2. Another thing we could do is we could subset for only the rows where the facility matches RK. So I want to look for only those employees who work at the RK facility. So I would say df, because that's my data frame, and then the brackets, because remember we know that we use those square brackets when we want to basically look for a certain row or column combination, because remember it's basically, this is our pattern, right? Our pattern for looking for stuff is the name of your data frame and then the row, column, or comma, column. So here what we're saying is, if you look over here, this is where our comma is, and it's blank after that. So we're saying look for all of the columns, but I only want you to pull the rows that match a pattern of RK, and specifically look within the facility variable. So within the general data frame df, we're going to pull all of the columns because we have our comma then a blank after it, but we're going to filter for just the rows where the pattern matches RK within that facility variable. And so when we do that, it returns a list of all of the employees whose facility is RK, as you can see. So it's all of the columns for those employees who are at the facility RK. And of course, you could make a new data set that basically contains these observations. Another thing I could do is I could say select only the columns that start with HR. And so I'm going to say data frame, apply the selection for starts with HR. When I do that, we can see it returned only those columns that have the HR in their title. Only those columns that started with HR actually, and it returned all of the observations because we didn't specify any row filter, we just said select columns that start with HR. We can also do select only the columns that end with something, so we'll say select only the columns that end with over. And so that's specifically only the turnover variable, but it returns all of the observations in that. So I'll scroll up. Geez, it's taking forever. Let's do this. Let me just store it as something, right? So let me just say df3 equals that, and then let's take a look at that now. And again, we returned just the columns that end with over, and that's only the turnover column in this example. And then the last thing that we can talk about real quick is some alternatives to doing what we've just done in tidyverse, some alternatives that use base R instead. So I'm not going to spend much time going over this because again, I've showed you how to do all of these using tidyverse. You can kind of go over this on your own time with the code on the website. These are just some alternatives. There's nothing new that I'm going to show you here really quickly. They're just other methods of doing everything we've looked at. So as an example, if we want to get the average pay by department, when we use tidyverse, we had to group by department, and then, sorry, we don't have a department variable. I don't know what I was thinking. Just 1 second real quick. Oh yeah, we do. I forgot. This is a different data set. So we do have a department variable. Okay, so before, if we wanted to get the average pay by department, we had to group by department with tidyverse and then apply a summary function average. Well, if we use base R, we can say aggregate, then we specify the variable that we're interested in, so the daily pay rate. We say what we are aggregating by or grouping by, so for us that's department, and then we say the function that we're applying, which is the mean, because we want the average. So again, x is the variable you're interested in, by equals list, and then you specify the grouping that you're grouping by, and then fun is the function that you are applying. So we are applying the mean function to employees' daily rates by department. And when we do that, we get the average pay for the human resources, R&D, and sales departments. And then there's some more examples. You could do the same thing with median turnover by facility. So we're going to look for the turnover variable by facility, apply the median function. And when we do that for each facility, we have the median pay. If you want to sort in ascending or descending order, you can just say sort, and then the name of your variable, x equals, and so for us we want to sort by turnover, so this is just going to give us everybody's turnover intentions in ascending order because I said decreasing equals false. If I want to get it in ascending order, descending order, I would just say decreasing equals true. So when I do this, decreasing equals true, this is descending order. And when I want ascending order, I would just say decreasing equals false. And so when I do that, it sorts all of my observations in order of ascending order, because again I said decreasing equals false, and again I just did the turnover variable. If I want to make a new column as a function of the old column, that was how we did mutation with tidyverse. Well, in base R, I could just say whatever my new column is going to be, so df, my data set, $, and then the name of the new column, it's going to be a mean-centered version of turnover, and then I specify the operator, so I'm going to save a new variable called turnover centered, and that's going to be the df $turnover, the original turnover variable, minus the mean of that original turnover variable. So I'm just taking my original turnover variable and then mean centering it and saving it as a new variable called turnover centered. And then when I go back and look at my df data frame, if I go down to the end, sure enough, there's my new variable. So instead of doing mutation like we did with tidyverse, you can just add the new variable by saying df, the name of your data frame, then the $, and the name of your new variable. And then we can also make a new column as a function of an old column, kind of like we just did, but another example. So I want to make the age variable, which was, all I'm doing is I'm basically taking, the difference here is that this is going to be the same variable as before, but I'm just changing what it is. So we already have an age variable in the df data frame, but we're just re-saving it as something else. So I'm saying df $age, so take the age variable from the df data frame and make it the old df underscore age variable squared, caret 2. So when I do that, if I look at my df, my age variable should now be really big. And sure enough, they are. And again, the difference between this and the old age squared variable is that I just saved over the age variable. I didn't make a new variable, I just saved over it as something that's different. And now you can do some filters. In tidyverse, when we had to apply filters, you don't have to do that. You can just, say, hey, take the data frame and then the brackets and specify your condition. So if I want to filter for all employees who are ages over 10 and I want to return all of the columns, I would say df and then brackets. Well, I want to filter by those employees whose age is greater than 10, and then the comma with a blank after it is how I specify that I want all of their columns. So when I do that, I saved it as the a variable, and if I look at it, sure enough, this corresponds to all of the columns and observations for every employee who is older than 10 years old. If we look at their, we squared age, so every employee has an age that's well over 10, but you still get the general picture. And of course, we don't have to save it as an object. I just did that because that's what you would probably want to do. You'd probably want to make a new data set that represents a filter of your old one, but you could also just get the values directly. And again, same thing. It's just whether or not you want to then store it as something else. Another way we can do this in base R is we can say subset and then x equals df, because that's our data frame. So subset the object, which in this case is our entire data set, take a subset of it where that subset is equal to age greater than 10. So subset, whatever you're interested in, and then the subset that you apply is going to be age over 10. That's the condition. So when we do that, we get the same results that we just looked at with the other method. Another thing I might want to do is I could say I want to filter for all employees where I just want to get only the age and turnover columns. And I think we actually looked at this earlier, so I won't spend much time. But again, this time, because we want all rows but only specific columns, we leave the blank in front of the comma, because that's where the rows are specified. So we leave it blank because we want all rows. C parentheses, and then the name of the columns we're interested in, the age and turnover columns. And then as we look at it, finally, again, it's all observations, just the age and turnover columns though. And a couple other examples that I won't go over, but yeah, that's pretty much it. I know this was a lot to take in. The best recommendation I have is just to get your hands dirty and play with this as much as possible. Thanks as always for watching, and please feel free to reach out if you have any questions. I'll post another video that goes over a more in-depth version of this later. And as always, the code is on my GitHub page, and thanks.